Hi guys, today's lesson is constant of proportionality. You need your handout. You need your binder and you need to open this up. So make sure you have that. If I go too fast, then just stop the video and write. You can do that. I'll also be asking you questions. This is on an ed puzzle, and so it will be graded. A relationship. So let's talk about proportional relationships. A relationship is proportional when the ratio of y over x um, is constant. Let me make sure I have my pencil here. Here we go. Is constant. That means that relationship, that y over x, y is always going to be on top. Every y over x is the exact same. It's constant. Okay. The value of the ratio of two proportional quantities, this is your constant of proportionality. It's the value of that ratio. It is represented by the equation of k. K is your constant of proportionality equals y over x. Y is on top, where y represents the dependent variable, and x represents the, what do you think it is? Independent variable. Okay. You use the equation y equals kx to represent proportional relationships. Okay, so let's see what that means. You have a table. Here's your x, here's your y. What did we say was on top? Y is on top. So that would be 6 over 1, which is the same as 6. Okay, what's on top? 12 over 2. And that's the same as saying 6. Look at that. They're the same. How about 18 over 3? What does that equal? 6. And then you have 24 over 4. What does that equal? 6. So what's our constant of proportionality? 6. See how it was the same for everyone? Then that is, because these are a proportional relationship, that's what it is. So let's do number 2. It would be 10 over 2, which is 5, right? And then we have 15 over 3, which is 5. And we have 20 over 4, which is 5. I should put an equal sign there. So our constant of proportionality is 5. I want you to find the constant. I want you to find this, the constant of proportionality for number 3. Okay, how did you do? Did you do good? I hope so. Now keep in mind that I put this on 2 times. So you get 2 tries on this ed puzzle. So if you messed up, you can do it again. Okay. When we're talking about constant of proportionality, we're talking about a constant ratio. So it's kind of like that unit rate. So you can do the same thing here where, remember, we put money on top. So it's going to be 2328 over 6. And so the money on top over the 6. Okay, 6 pounds of almonds cost this much. This is the one that is independent. This is the dependent. And so if you calculate that out, you're going to get 3.88. That's your constant of proportionality. And so that 3.88 is what it's going to be like. If you had 7, you would have a number, it would be 7 times the 3.88. If you had 8 pounds, it'd be 8 times the 3.88. Okay? You try number 5. Remember, miles is going to go on top. And let's see what you get. Did you get it right? I bet you did. And if you didn't, you can always do it again. Okay, when you're using a graph, so now you see how to do it from a table. From a table, you just do y divided by x. Now, what do you do when it's from a graph? Well, let's look at a graph. You can just make a table. That's one way of doing it. Just make a table. So when I'm at 0, I'm at 0. 0, I'm at 0. When I'm at 1, I'm at 10. 1, 10. When I'm at 2, I'm at 20. Oh, looky. Do you see it? Do you see the constant? When I'm at 3, I'm at 30. 3, I'm at 30. So what's my constant? 10 over 1, 20 over 2, 30 over 3. What is my constant? My constant is 10. Okay, and so what does the point 1, 10 represent? Well, 1 right here is tickets. Right here is cost. So 1 ticket costs $10. That's what that represents. So on number 7, I want you to do number 7. I first want you to make a table, and then I want you to give me the K, the constant of proportionality. So keep in mind, it's hours and miles walked. So you try number 7. Okay, did you get 3? I hope so, because that's the answer. What does the point 1, 3 represent? Well, that represents 1 hour walked, and you've gone 3 miles. I don't know if I can do 3 miles in 1 hour. I'm kind of slow. Okay, let's move on. So, last question. How easy was this today? Right while training for a marathon, Keith's watch reported the number of calories he had burned at each mile marker. Okay, the data is shown below. So at 1 mile, he burned 117. At 2 miles, 234. Is the number of calories proportional to the number of miles? Justify your thinking. Well, I would say yes, because every time I ended up adding 117. Do you see that? So if I took 234 and I divided it by 2, I get 117. Okay, because 2 and 0, 3, 1, 2, and then 14, and then 7. I get 117. If I take 353 and divided it by 3, I would get 117. So the answer would be yes, because the rate is constant. It's constant. Okay. What is the constant of proportionality that relates y, the number of calories burned, to x, the number of miles? Well, that was 117. Write an equation that represents your relationship, the relationship. So do you remember we said up here that the equation was, do you remember way up here? We said the equation is y equals kx. Well, that's what we found out, this right here, the constant of proportionality, that's our k. So we would just say y equals 117x. Okay? The next day, Keith ran 7 miles. How many calories did he burn? Well, all you have to do is remember, number of miles is the x. So if we look at this table, this is the x, this is the y. So the number of miles is the x. So we're just going to put a 7. So we're going to go y equals 117 times 7. Okay? And then that would give us our answer. And the answer there is 819. Okay? But if Keith's watch reported that he burned 1170 calories. Okay, that's the Y. That's the Y. How many miles did he go? Then that would look like this. So you have to solve for X. So we're going to divide by 117, divide by 117. And did you get the answer? The answer should be 10. Okay, that's it for today's lesson. My class needs to do the next page. Oh, I just gave all the answers there. My class needs to do the next page, which is the practice page. It comes right after, and that's what you're going to finish class with. Thanks.